Today, we will be talking about subsurface drip dispersal or drip distribution. This system consists of a small diameter, pressurized distribution network that delivers small, precise volumes of pre-treated effluent at slow, controlled rate. This slide presentation is brought to you by the Consortium of Institutes for Decentralized Wastewater Treatment through a grant by the National Decentralized Water Resources Capacity Development Project with funding provided by EP. Drip distribution is a miniaturized version of pressure distribution, only emitters are used instead of orifices. In comparing drip distribution to pressure distribution, the emitters are very small, allow just drops of effluent to flow out. Flow is measured in gallons per hour rather than gallons per minute. There are 5 to 10 times more emitters than orifices in the distribution network, and emitter flows are less than 20% of orifice flows in pressure distribution. You can find the performance and design requirements for subsurface drip distribution systems in Arizona in R18-9-E322, which is on page 86 of the PDF version of the code. This is what a typical system would look like. You have the house providing the source of wastewater. The wastewater is pre-treated in a septic tank, is discharged to a pump tank, goes through a filter of some sort, then is distributed through the network of drip lines. The mechanic components of drip distribution is the pump, filter, pressure regulator, and controller. Here's another way to view how the components fit together. Moving from left to right, you have the pretreatment system, which discharges to the pump tank, that discharges to the filtration unit, that discharges to the drip field containing the tubing, emitters with orifices, different valves, and air relief valves. Each system has a supply line and a return line. The return line is used for flushing. There are 2 primary manufacturers of tubing used in wastewater. The emitters are manufactured within the tubing as shown in the upper right photo. The bottom right photo shows you an air relief valve. A drip distribution system may also have pressure regulators, filters, ball valves and/or solenoid valves, check valves, and a variety of fittings and connectors. A drip distribution system operates on a timed cycle and is pressure dosed. The effluent is filtered through a less than 100 micron filter. A supply line feeds the manifold and drip lines. Effluent flows out of the emitters dripwise into the soil or receiving media, since it can be used as the distribution method for media filters. By design, a solenoid valve or manual valve periodically opens and the drip line in the drip field is flushed back to the pretreatment process to keep solids out of tubing. Usually filters are back flushed each pump cycle. It varies depending on the product being used. Usually automatic flushing of drip lines and filters is used, though manual flushing may be used for certain situations. While the pressure in the tubing may be 45 psi or greater, the pressure when the effluent is discharged from the emitter is 0 psi. The flow drips out of the tubing. Capillary action in a dry soil helps move the effluent in all directions, assisting in both the treatment and dispersal of the effluent. Flow in coarse soils may be more vertical due to less capillary potential, as shown in diagram B in the lower right, while the flow in finer textured soils will be more in all directions, as shown in diagram A. So why would you use drip distribution and where? You would use it to obtain the most efficient uniform distribution. You can use it anywhere where gravity or dose flow distribution is used. For example, you can use it for a soil treatment system or for dispersing effluent over a media filter. In Arizona, you can use drip distribution to overcome site constraints such as high groundwater, shallow soils, slowly permeable soils, or highly permeable soils, or if water conservation is needed. You can place the drip field on sites that have lots of slopes or lots of trees. Just drip distribution installation methods cause less site disruption than other options. And in Arizona, drip distribution may reduce the downward percolation of effluent by enhancing evapotranspiration. The Arizona Code specifies that the treated wastewater that is delivered to the drip dispersal system used for final treatment and dispersal meet either a 20/20 or a 30/30 quality. That is, 20 milligrams per liter of TSS and 20 milligrams per liter of biochemical oxygen demand, or 30 milligrams per liter TSS and BOD5. For the cleaner quality effluent, the designer can place the drip field to the depth that will prevent ponding on the land surface, whatever that is. For the less quality effluent, the emitters must be at least 6 inches below the surface with a cover material to achieve a total emitter burial depth of at least 12 inches. When designing drip distribution systems, you need to consider the following. The effluent must be filtered. Time dosing is usually required so that the drip field is dosed and allowed to rest all day long. Although filter and lateral flushing can be done manually, it is usually done automatically. And the point of discharge to the soil is at the pipe, not the bottom of the trench or bed, so it's pretty close to the surface. You will want to use pressure compensating emitters because they discharge the same flow regardless of the system pressure, which is usually between 7 and 70 psi. Non-pressure compensating emitters will discharge varying flows depending on system pressures and elevations. You will use an area loading rate in gallons per square foot per day to size your system rather than sizing using an infiltrative surface at the bottom and sidewall of a trench or bed. Normal recommended maximum lengths are between 250 and 300 feet, although longer lengths are feasible depending on the number of variables, just like for pressure distribution, including type of emitter used. Usually, designs call for one emitter every 4 square feet. This usually leads to a grid with orifice and drip line spacings of 2 feet. This may change depending on soil texture, slope, and local requirements. Multiple zones will reduce the size of the pump, but will increase the cost and system complexity. A variety of installation tools are available to install the drip line. As you can see, they are very specialized, and rarely are they in the installation professional's stock of equipment. When installing drip tubing, remember that drip line can kink. Be sure to use flexible tubing. The recommended minimum install depth is 6 inches, and you'll want it a little deeper in cold climates. And don't stretch the tubing. That weakens the walls of the tubing and then tears can